I'll tell you a little about what we're doing and why we landed up doing this. But first, to start with this predicted global extinction crisis from climate change. So we've been hearing about it for a very long time. In fact, really back to the 1980s, where the alarm was raised about what climate change was going to do to us, but also to nature. And in our very most recent report from the Intergovernmental Panel on Climate Change, this very famous diagram has been updated and shows again the different systems of planetary systems and when they come into their highest levels of risk. And the most sensitive is this reason for concern number one, unique and threatened ecosystems. And you can see that here as the temperatures rise, we head into this very high and high risk area. Now, earlier this year, we crossed the 1.5 degrees centigrade average increase in temperature around the world. Our average for the year sits around about 1.3, 1.4, but we've hit that 1.5, which is the threshold that everybody considers to be dangerous and where we don't want to go. So we're sitting in that high to very high area. So where's these extinctions? Where's it happening? What's been happening? I'm going to take us back 20 years to Camille Parmesan, who was a student at Texas A&M University doing her PhD on Edith's checker spot butterflies. She discovered this very surprising pattern in where they were becoming extinct and where they were moving to. And they were moving uphill to higher elevations and to higher latitudes where it was cooler. And this was one of the very first impacts of climate change. It showed that pattern of species moving to cooler areas by going towards the poles and to going uphill. And that was very exciting. It was huge. The fingerprints of climate change, it really kicked off our field of study. Now, I was a student around about that time, and the Namibians came through it spoke to the South Africans. I was at the National Botanical Institute, and they said, look, our quiver trees seem to be dying. Are yours? And so Guy Midgley, who was my supervisor and working at the center at the time, was quite switched on. And we didn't know, the South Africans didn't know. But he thought, well, let's have a look and see if this has any patterns related to climate change. And I took on the project as a master's student, really not believing in climate change. And I kind of just wanted to work in desert systems. So I took it on, and I was set off to prove them wrong, and that it was going to be something like a disease or something's going to eat them, or I don't know, whatever, but it was a cool place to go. So off I went, and that's where the quiver tree occurs. And over the next 2 years, 2.5 years, I carried on after my master's, I went and surveyed these quiver tree populations, 44 populations across the species range, about 2,000 kilometers. And it occurs in both summer and winter rainfall areas, quite cool and quite a very hot area. So it's quite a broad tolerance that it can deal with. And its most northern range distribution up here is the Brandberg and the Spitzkoppen areas. So there you can see trees on the top of the Brandberg. Quite some effort to get there, I can tell you. 45 degrees heat. But there they are. Quiver trees. So why did they get there? Why are they called quiver trees? Well, they got their name because the sand bushmen would break off the branches. They have a very hard outside shell and very soft and pithy inside. So if you pull out the pithy bit and put a piece of skin over the end, you've got a really fantastic quiver for your arrows. I don't know anybody who doesn't love quiver trees. They really are an icon of the deserts. They're on the Namibian coins. They are the emblem for Richtersveld National Park, jewelry. As Kirsten mentioned, that famous population up near Keetmanshoop is a real tourist attraction. So yeah, we love them, and they're important to us. And they are responsible for quite a lot of money from tourism as well. And they're also really handy because they live a long time, and when they die, their skeletons remain in the population for some time. So you can tell from the size of the live trees when they're recruited, and also from the dead ones, how the proportion of live to dead, how that population is doing. So I went out, as mentioned, and spent that time in the field looking at these trees. You can see there's a little baby. They often grow little nurse plants coming up. And we measured all manner of things like their disease, the predation from like porcupines and baboons, and how many branches they had, and basically various measures related to their health. And in the end, what we discovered is this pattern of where they were doing well, basically of mortality. So you can see in some of the populations, particularly in the south and the high elevation areas, they were doing really well, very low mortality. But in the areas along the Namib and further down and lower in elevation, they were doing particularly badly, with up to 75% mortality. We looked at the trends in latitude, just like Camille Parmesan did, and found that there was that same pattern, that these trees were doing, of course, they're not butterflies, they can't move to the cooler places, but they were doing much better where in the cooler parts of its range. And that related very clearly to changes in dry months and aridity across the last, basically across the 40 years before that. So that was really exciting. We wrote a paper and concluded that we are seeing this contraction on range. The gray is the area where the climate is predicted to become suitable. And in fact, the areas that are unsuitable were largely where we were finding these dead trees. So it was really exciting because now Africa had an example of a climate-driven range shift. And it was one of the first plant ones, one of the first arid ones. And so there was a lot of uptake on it. You can see Leonie Jabert's book on climate change in South Africa. We were on the front cover. BBC came and made a documentary about our work, and IUCN picked it up as an example of flagship of climate change. Everyone loved it. It was in the papers. And one of the questions everyone wanted to know is, so these Kruger, they're marching south. And how fast are they going to march? And when are they going to come to Cape Town? Because we like them. I want them in my garden. So people got excited about the study. But now it's 20 years later. And what happened? Were our predictions correct? Or weren't they? Fantastic opportunity to find out. So in that time, I landed up leaving Sandby and going overseas, working for IUCN in Cambridge. But I continued working on climate change. Some of the work we did was, I meant to say first that this is the sorts of changes that we were seeing over that time. So changes in annual mean temperature and in precipitation and our soil moisture change. And so this is at about 1.5 degrees, which is roughly where we're about to be. Something to note of this, that the world doesn't warm evenly. The land areas warm much more than the ocean. And so 1.5 degrees means a whole lot more. And in Africa, it typically means double the global average. So you can see already that we've had a lot of warming and we happen to be unlucky in our placement. The Arctic is the most unlucky. But we're not in a great place. And when it comes to precipitation change, our western part of our country is amongst the unluckiest in terms of warming and drying. So that's what's predicted, and that's what seems to be playing out. And as I mentioned, I carried on working in this field, and we carried out a study where we looked at climate change impacts right across ecological systems. And by 2016, we had already found that 82% of processes had been impacted. And we call that the boot print of climate change, really. Tipping our caps to Camille Parmesan's fingerprint study. In that time, I think we've all heard about the coral reef bleaching, mass bleaching, particularly of the Great Barrier Reef, but really everything in most places where they occur. in North America, the pine bark beetle, which is actually an indigenous species, has not been knocked back the way it used to by cold winters. So now it's proliferating and taking down large amounts of the temperate forests of North America. Huge ecosystem shift there because fire comes in. In Australia, the spectacled flying foxes, which were a common and least concerned species, in a series of very hot nights, physiologically they just crossed a threshold, could not handle it, fell out of the trees, and 22,000 of them died over a series of just a few days. That's what it looked like. And similarly, the picture on the left is from Kerry Gray, a colleague of Kayleigh's and mine, and she's been working in Swali in the Kalahari. This is what she witnessed in February. As yet undocumented scientifically, but there is one that was in KwaZulu-Natal last year, and that's that was a mass mortality of birds there. Similar things have been happening with the spider monkeys in Mexico. Again, they just can't handle it and they fall out the trees. So really distressing. Mammals are very vulnerable, needing to keep our body temperatures constant. This is something I witnessed myself in Tanzania. The rains are coming a month later, and these hippos are waiting, just waiting, and some of them die and they just get stuck in there. And two extinctions have happened. One is the bramble K. malamus, that little rat. He was in a little coral island north of Australia, and during a big storm and with sea level rise, the ocean washed right over it. We knew it was there. It was being monitored by scientists, but no one thought to collect it, and it's now extinct. The golden toad from Costa Rica has gone extinct through a combination of loss of the cloud, the orographic cloud in its cloud forest home, and pollution, and a fungus. So these threats often work in conjunction with each other. Sandparks has experienced a lot of impacts, floods. The UCT fire happened on an extremely anomalously hot and dry day, bush encroachment, sea level rise, and drought. And our arid systems do seem to be taking the biggest pounding and seeing the most immediate impacts. And this is proving to be true across deserts across the world, North America, South America, and Australia. Impacts very specifically on mammals and on reptiles, but those that can burrow seem to be doing better. A lot of work on birds that at least can shift their ranges, and we don't know what's going on with invertebrates. Too little studies. What about this? Who remembers this album? Joshua Tree. Talk about charismatic. So those are the equivalent of our quiver trees to North America. And they are really beautiful, but then they look quite similar, right? They're functional equivalents. They have exactly the same role in the ecosystem, and they have a whole national park. Joshua Tree National Park, of course, is one of the most famous parks and hugely visited, not far from LA. I was very fortunate to get to go there last year and spend some time with some of the scientists there talking about their conservation. And the biggest challenge they face is fire. Interestingly, the hotter temperatures and the new conditions have allowed grass to come in under these trees, and they never previously carried fire. And now the grass is bringing fire into these populations that were completely naive to it, and the trees are burning. So, yeah, they now have the challenge of climate change burning the trees literally, and that has happened to some of our quiver tree populations too. Again, saguaro, these crazy beautiful cacti are seeing some of the same impacts as well. And they're the equivalent in their South American systems and Mexican systems. And these are our pachypodium. Look familiar? This morph is also really struggling. All these large stemmed succulents seem to be battling, and this is a picture of it's over about a 20-year timeline, and these species are lost, potentially, well, definitely also some of it being harvested illegally by people for the ornamental trade. But what about quiver trees? 20 years on. So what's happened to us? So we've gone out in the field. It's taken us about 6 years of springs and autumns to manage it. And we have done some of the most fabulous field work, incredibly intense. And there are some pictures of us. We got to go some of the most beautiful places that you can imagine. And so now I'm just showing you some gratuitous holiday pics, field work pics. Hmm. It's from the top of the Brandberg. That's in the Namib Nachtlucht. And these are some of the people who, over the years, have been helping with the field work that we've carried out. We've now measured these trees, tens of thousands of trees, and close to now 50 different populations. And in each one is 100 trees measured, and all of those measures taken about their population health. So thank you to all of them, some of whom are on the call. And particularly, the two students, Kayleigh Murray and Kerry Gray, became particularly involved in the work, and they did their MScs on the quiver trees, various aspects. And Kayleigh is going to tell you a little bit more about her study and what she found. So Kayleigh, over to you.
As Wendy said, hello everybody, I'm Kayleigh Murray. I'm the very lucky student who's been able to do this quiver tree research with Prof. Foden for the past couple of years, and I've been doing field work to assist different students and the monitoring efforts on it for around like 5 years now, 4 or 5 years. I met Prof. Foden once when I was in undergrad, and she showed us this research on the quiver trees, and I was very moved. And I said to her, if you ever need a field assistant, please let me know. Here's my number. And she did. And so once over the years, I've been working in conservation between my degrees, and I was doing an internship at the Stellenbosch University Botanical Garden. And Guy Midgley and Wendy approached me and said that they'd like to do a population genetic study on the quiver tree eventually, but that first we need to clarify exactly how old the trees can get and exactly when the dead trees died in order to do that. So I kind of started heading towards setting up a genetic study and collecting seed for conservation at the Stellenbosch University Botanical Garden, but endeavored to start finding out these kind of basic demographic values for the trees. And so the reason being that there were some questions, or when you're trying to assess the vulnerability of long-lived species to climate change, the problem is that they live for so long and their population dynamics play out in such a long time scale that it's sometimes difficult to differentiate between whether the trees died recently or if their populations are shaped in the way that they are because of historical changes. So, for example, people had asked about the quiver trees. Are the dead skeletons that we're counting as the metric of mortality, did they die because of climate change, or did they actually die in the 1940s and then it took them really long to decay? So that's why they're still there. And the other question is that are some of those populations that have very few individuals, just a few adults and very few juveniles, do they just exist in a place where the climate degraded further into the past and then they just persisted there in a place where quiver trees aren't actually meant to live anymore? So they're not necessarily declining because of climate change, but because of longer term changes. And you can find that out, but by doing more kind of genetic studies that look into the deeper past. And in order to do that, you need a very accurate means of estimating how old the trees in a population get. And so historically, the way that people had estimated the maximum longevity of the trees was by looking at repeat photographs. And there was a study that looked at repeat photographs of 4 individuals that they knew were the same, and estimated that they would only live until about 150 years old, which seemed to be a little bit short. And in Foden's paper, she estimated based on anecdotal evidence from other people that they would live to be about 350. But you can never observe the entire lifetime of these trees because they're very old. Likewise with the decay rate, to try and figure out when the trees died in order to see whether they started dying because of anthropogenic climate change, they would look at repeat photographs of the dead trees that were being monitored to try and see when they died. But we needed a more precise way of understanding these different rates. So with longevity, people would immediately, or you'd think of counting tree rings, right? So with dichotomous plants, the trees put on rings every year in a predictable fashion. So you can count them and then understand that the oldest material is at the center, the youngest is at the outside, and this tree is so many years old. But even though you can see it in the picture on the right, that is the base of a dead quiver tree, they do have rings. But we don't know how they put those rings on. We don't know if they put them on every year. We don't know if it's influenced by temperature, by rainfall. And so it couldn't necessarily be used as a reliable means of counting their years or their age. And this is a persistent knowledge gap in monocots. So monocots are the group of plants that grasses and orchids belong to. They've actually lost the genetic machinery that allows them to grow outwards laterally like a tree trunk compared to dicotyledonous trees. But there's one weird group, and I saw someone in the comments brought this up. There's a weird group of Asphodelaceae that have evolved the monocot cambium that allows them to grow into a tree-like appearance, grow outwards laterally. And we just still, these are the dragon's blood trees, the dracaenas, as well as the Joshua trees, the Yuccas. But it's still unknown how old each of these can get. And growth rates can differ, and we don't really understand that yet. So one of the means of being able to age plant material is radiocarbon dating, which you can use to actually find out the age of samples that you take from the tree along the trunk, from the center to the outside. And we were given the opportunity to do that with Itembe Labs in Gauteng and Dr. Stefan Woodbourne. So just a brief introduction to radiocarbon dating. In the atmosphere, we have nitrogen and carbon. And carbon-12 is the most common form of carbon, but there are some other types. So they're called isotopes. They're just different types of carbon atoms. But carbon-12 is the majority of the carbon that you'll find in the atmosphere. It has 6 protons and 6 neutrons. But in the upper atmosphere, nitrogen atoms also get hit by cosmic rays and converted into a type of carbon called carbon-14 or radiocarbon. This has 6 protons and 8 neutrons, and it is radioactive, meaning that it will decay and turn back into nitrogen-14 over thousands of years. But we know its decay rate, so we can use it to date material. Another cause of carbon-14 in the atmosphere was the nuclear bombs in the 1950s and 60s, when America was running its nuclear weapons testing in the South Pacific Islands. And so both of these types of carbons get fixed into CO2, and that gets taken up into a tree or into all living organisms. So plants take up the carbon, and then animals will eat them. And what we can do is we can take samples from the trees and then find out when the sample was formed based on the ratio or the amount of carbon-12 to carbon-14 in that sample, and using the known decay rate of carbon-14 over time to assess when that sample was formed. So essentially what we did is we used the Itembe Labs accelerated mass spectrometer, which is a very big fancy machine. And we put a sample of the quiver tree in. That's in the bottom left corner. That's what the dry quiver tree trunk looks like. And then it's burnt, and the carbon dioxide gas is captured, the smoke's captured. And the machine counts the individual number of atoms of carbon-14 and carbon-12 in that sample. And then based on the ratio and doing a calculation of the radiocarbon age, because of how the carbon-14 decays, we can compare it to a graph of known concentrations of these atoms of this ratio throughout history and convert that into a calendar year that gives us the age in calendar years of the actual sample. I know this is a very brief guide to introduction to radiocarbon dating, and I don't think I'll go through this, but it's important to note that with those samples, you won't always get just 1 year returned. You will get multiple years, but then you can select which one is most likely. And it's a means of giving you pretty much exactly a year of when the sample was formed. So what we did is we sampled from a couple of trees in the desert in the northern Namib, where we expected the trees to grow quite slowly and to be the oldest, essentially. And I'll zone in on one tree from a place called Bloedkipper, which is a campsite in the Namib Naukluft Reserve. And so what we did is take samples from the inside sequentially to the outside of the tree. And then we would expect, as you can see in the graph on the left, we would expect the sample at the center or nearest to the y-axis to be the oldest and the sample at the outside to be the youngest. Unfortunately, that's not what we got at all. That's life. Nothing is ever straightforward. So I got this kind of mess of a graph in my master's and was sitting there with my head in my hands trying to figure out what I'm seeing. And I'll try and explain it to you as best as I can. But what you see is that the dots look like lines, essentially. And what that represents is that each line is a sample. It's all of the possible years that sample could have been formed in. Because, yeah, you get a few different options of years. The second thing is that if you look at the y-axis and then the second sample out, those two are relatively young. The sample that's on the y-axis, which is at the core of the tree, is pretty much as young as the outermost sample, which means to us that the tree is fixing carbon at the center of the tree throughout its life. It doesn't die like in dicotyledonous trees. And we found this consistently across every single tree that we sampled, and we've sampled across all populations now at around 35 populations. This is not recorded in any other monocot trees, so this is previously an unknown growth pattern. And very exciting to find out, but also very annoying because it means that the oldest material in the tree is gone and we can't actually know what the oldest age was from that. So luckily, if you look down at that third sample, you'll see something quite remarkable, and that it's a lot older than we thought it would be. The sample formed between 1277 and 1452, making it 747 years old or 500 to 572 years old. The sample, like I said before, the trees grow upward for quite a long time before they start putting on lateral growth. And so that means that this tree is likely would have to be older than that sample. And so we can't really draw a line from the younger sample to this oldest one to try and extrapolate what the oldest would be. We have to use a more complex modeling to figure out what the oldest age would be. We used a Bayesian model, which draws millions of different lines through here to figure out what the oldest age would be. And essentially what we got to is that this tree from the desert would have been around 750 years old and would have died in the 1960s. I'm still honing the method of understanding when the trees died, but we are also getting preliminary information about when most of them died, and it does seem like most of them died after 1950, which would address the issue of when did all of the trees, the dead trees that we're counting, die. Yeah, and so it's been an absolute honor to study these trees and to work with Prof. Foden. I'm just the luckiest young researcher, and have to have discovered this incredible thing about this tree that sparks so much excitement in everyone. But I'm going to hand back over to Wendy now. Thank you.
Thanks, Kayleigh. Yeah, really exciting master's project, an incredibly tough one, and Kayleigh's done an amazing job. Yeah. So back to our population studies with the knowledge that we have now that these trees live more than 700 years. Now, a good indicator is something like a butterfly that with the tiniest little change is very sensitive. And now we find that, in fact, our quiver trees are a really very bad indicator because they're so insensitive. They're used to just sitting there for 700 years and taking whatever droughts and horrible weather comes to them in the Namib. So, okay, now maybe our study's not going to work at all. So what did we find? Well, these are some of our repeat trees that we've tracked down. And in many cases, you won't be surprised now to know that absolutely nothing happened in 10 years or even in 20 years. Then in some of the other ones, you find, for example, these dead trees that we look at over that time period. Again, very little change. You can see a little bit of decay around that edges, and that's in the Richtersveld. Then some of the young ones, some of them didn't make it. Again, that's Richtersveld. Some of them did really well, and you can see how much they've grown. You can also see in the background how these are quite useful for seeing changes in the environment. We came to some populations. I was so excited to show Kerry and Kayleigh some of the most beautiful Namibian populations because we got to go around Namibia on a big field trip. And this one just north of the Orange River, we found was about 80% dead. Yeah, it was very, very disturbing. This is another one of the most dramatic and beautiful sites. This is the densest and largest population I think we've seen. And when we came back, really not looking good at all. This is a little video. You don't need the sound. This is what it looked like standing there. It's very, very disturbing to have gone back for such a short 20 years and see it looking like that. So over such a short time, really dramatic impacts and nobody noticing. These landowners barely notice. Some of them don't notice these things at all. Some of them are disturbed, but most of these places it's just happening and no one's noticing. This is Koekoeboom Kloof campsite in the Richtersveld, now also about 75% dead. So, yeah. And yet, further south, some of these populations were just going nuts. Babies everywhere. Look at them. You can see baby, baby, baby. I'd never seen anything like that 20 years ago. They really have taken advantage of things. And a sort of a brief snippet, Kerry's master's was around looking at the cold range dynamics. And she showed how these populations are getting benefit because they were previously limited by it being too cold. And the warming has just been great for them. So this is the sign of them marching south, except it's very slow. They aren't going very far. So this is what we found 20 odd years later. So on the left is the map that we published in 2007, and this is the cutting, just hot off the press, not yet published patterns on the right. And you can see, as predicted, that the ones in the south are doing well, and there's been massive mortality. I mean, we didn't even have that category of 75 to 90% dead in 2003. And several of these populations are really on the brink. One of them is 89% dead, and particularly along the Orange River. And you can see the steady increase. It's a statistically significant increase in the mortality over time. And these are species that are supposed to be really tough and live for so long. What's happening? These are the patterns of juvenile recruitment. Apologies that this darker, this gray is the lowest. Is the highest recruitment. So again, you're roughly getting a pattern of recruitment happening in the southern populations, but it's not statistically significant. What you can definitely see though is that the recruitment is not making up for the amount of mortality that's happening in each population. You can also see that pattern, that latitudinal pattern of the trees dying in the south dying in the hotter range edges in the north and not in the south is playing out again in each of these decades that we do this monitoring. It's quite a clear signal. So that is big news. But the quiver trees themselves will probably be fine because they've got all of these young and healthy populations here, even if we lose them in much of that range. Tragic as it is, the species will probably not go extinct. However, it's got these sister species, the giant quiver tree and the maiden's hair quiver tree, that only occur in the Richtersveld area. So they're really much more sensitive because they haven't got that opportunity to have a lag between the first ones affected and these ones in the south expanding. They all get hit in the same way at the same time. So we're really, really worried about them, and they're both showing drastic declines. And we don't have the same level of monitoring data on the Aloidendron ramosissima. So it's work that we are planning to start soon, just waiting for some funding. For some funding. Now, the Richtersveld area seems to be being extremely badly hit. And this is a figure that shows aridity index over the last 100-odd years. And you can see how the 1940s drought was very brutal, and then we seem to have these years where we recovered, but in fact, this is even worse than then, and it hasn't really recovered since 2000. We get a few rain years, and it's not good. Now, I'm sure many of you have been up to the Richtersveld. If you don't, it is a World Heritage Site, both for its biodiversity and its cultural significance. It's a park that people live in, and it is ridiculously full of incredibly beautiful plants. And in fact, in this Gariep region alone, we have 5,000 or more species with extremely high endemism. And putting it in perspective, the UK, it has only 1,692 with 5% endemic. So we have just a world's treasure up here in our Northern Cape. That's David Attenborough's comment on it. We are so lucky to have it. It's so beautiful. But it's subject to a whole range of threats. Drought, of course. The livestock are grazed in the park, but when you have big droughts, obviously the carrying capacity is much lower, and as our temperatures, the climate changes, your carrying capacity is lower, but the livestock numbers are not. They're agreed numbers, and they're not declining. There's a lot of mining, and now it is subject to the green hydrogen project, which is solar and wind turbines. And the wind has, in fact, increased because you end up with hotter temperatures on land and bigger upwelling, so this bigger differential and increased winds blowing off the land and into the sea. And that sand is pummeling everything. And the mining and the overgrazing break the crust so that sand is even more mobile. So it's really problematic, and we have two species that we cannot find. We knew where they were locally distributed. We cannot find those two anymore, and they are probably extinct due to that sand blasting. And then, of course, sorry, pushing the wrong way. So basically we have real challenges, and of course on top of it we have the succulent poaching crisis, which is another talk that needs to be made about what's happening there. So what do we do about it? How do we respond to that as conservationists? What can we do? So I'm going to talk a little bit about that. So if you really, really want to save something and you've got a lot of money, you can try some pretty extreme things. So these are, that's the Rhone Glacier, and they're literally putting blankets on it to keep it cool, white blankets. If you really want to ski, that's what you can do. This is the National Park Service in the obviously in the US, and there's their giant sequoias and some of their cultural heritage that they want to protect during fire. And if you've got the money and the will, that's what you can do. In Joshua Tree National Park, what they're trying to do, that is a little more difficult to get rid of that grass. So they're talking even about bringing cattle in to graze the grass. But the climate is changing too. And so what they've done is found an area that is the coolest and the area that is likely to stay climatically suitable the longest within that park, and to try and actually till and carve out a fire break beyond fire breaks to protect the very last refuge for these trees. Sandparks has been trying some novel things too. So this is in the Tankwa Karoo National Park. UCT researchers have shown that although these little birds are incredibly tolerant to high temperatures, they do this through panting. So the evaporative cooling from their mouths cools them and cools their blood, and that's how they survive. But they need water. And one of the challenges is that while they can survive about 50 degrees air temperature, which is the maximum air temperature, the ground gets much hotter, and that means they can't land to get to the water. So what we've tried to do is build these little frames, cheap and at this stage quite experimental, but just to shade the edge of the waterhole to allow them to land. And just do this in heat waves. At the moment, we've actually got them still standing. So we're still doing some research to see the impacts of this on the bird communities. But it's the kind of novel thing that we need to be trying. We can't just do the same as we were. These are nest boxes up in the Kalahari to help birds roost without their eggs obviously getting denatured due to the heat. This is up in the Richtersveld, where we've built a net house for some of these species that, for example, those two that have now gone extinct outside, we have got them now in this nursery. They're here, and those are misters to keep it cool. And this is where we're putting them. We're shoring up. This is our insurance, and there are now, I think, 5 species that we're pretty sure are extinct outside. So yeah, we're just getting a move on, and it's not a great cost. We've raised a little bit of money, and we can do quite a lot with that. So here are some of the plants that we're growing. We're also taking in the confiscated materials from the succulent plant poaching. Here's another interesting one. This is led by BirdLife South Africa. So we know that penguins are struggling because their main food sources moved from the west coast round to the east. Algoa Bay areas now where they're most food. And so we were hoping that we could entice them to move from the west closer to the food source. And they're very loyal, unfortunately, to their breeding ground. So how are we going to convince these penguins? They're not necessarily the most sharpest birds on the block. And so what they did is found an area in De Hoop National Park where they had used to breed a long time ago, but no longer do. And fenced it off from predators and tried to entice the birds over. So you're seeing little rubber decoys there. And so they'd go near the population and hope to spot a penguin, then throw the decoy out behind the boat and try and entice this bird to come along and show it where the new colony was, where they had mirrors set up and calls of a whole colony of penguins, so that they felt at home and welcome. And I'm glad to say that after about 10 years, they've now had 6 chicks born in that new colony. So it seemed to be working until a honey badger broke in and killed a lot of them. But anyway, so it goes, the dangers of small populations. But if you really want to keep them and they're a high value species, then you've got to be innovative and try some new things. I think that I'm going to stop there because we are short on time. I'm happy to answer some questions around this. But I think, Kirsten, that we should have a break there, or we should end there rather.
Okay. Thank you, Wendy. Thank you, Kayleigh. That was really amazing. And as I see, Dr. Martin has said so beautifully. Thanks to both presenters. Really appreciate all the caring that has gone into these studies. Yeah, it's just obvious that your dedication and your passion is just wonderful. And yeah, for this iconic species, and obviously representative of many, many more species that are in risk, in a crisis. Thank you both for your lovely presentations. So I'm going to open the floor up for any questions. Maybe I can just kickstart with one. Wendy, I was quite excited when you brought up the penguins. All my colleagues will tell you I'm very passionate about penguins, African penguin, and we had a Unlocking Nature a little while ago on the penguin situation and teetering on the edge of extinction. And one of the things that we question is these penguins are being rescued from the ocean and fed up because they're completely malnourished, and they're fed up and then re-released into the ocean. And then, yeah, probably the same ones get pulled out again at some point and re-fed up again. And that brings me to a question about the quiver trees. Is there a point to conserving species if there's no suitable climate left for them in the wild, and they can only survive in gardens or greenhouses?
Yeah, happy to answer that. It's a really challenging issue, both conservation-wise and and conceptually and heart-wise. There are so many species that are getting in trouble. And our Richtersveld seems to be one of the very first places in line, and there are so many species. So, do we aim for all of them? Is that even possible? And I think one of the things to bear in mind is that it really shifted my understanding when I realized that climate change isn't just a one-way thing, that it carries on getting hotter and hotter forever. Given the decline in world populations and the responses that countries have committed to, let's not talk about the US election right now, but that they did commit to under the Paris Agreement, we will peak, and then the temperatures will start to go down next century. So we are not on a one-way ticket to Hades. It's a time of extreme heat, and when we come back down again, if we still have that material in safekeeping, we can begin to put it back out again. And I think for evolutionary purposes, the more that we can keep and use as seeds for the future of evolution, the better.
Thank you, Wendy. Yeah, it's good to have hope. Thank you. Kayleigh, can I ask you a question as well?
Sure.
Great. So, yeah, it's absolutely amazing. These quiver trees that can get up to 700 years old or more. It's just absolutely unbelievable. How does that compare to other species like Joshua trees, giant cacti, or baobabs?
So this is the thing. It's definitely one of the oldest. It's definitely the oldest monocot that has been recorded or studied. That doesn't mean it will be the oldest overall. It just might mean that it's the first one that we've recorded and found. But for example, baobabs, which are a dicot, they will probably grow, or their recorded ages has been around 1,200 years old. I think the oldest is a little bit older than that. But for angiosperms, this is quite long. We get other trees like the bristlecone pines that are gymnosperms that will grow for 4,500 years. And it's the same thing. Those trees actually don't even eventually die. It's just that the environment around them changes so much that it can't sustain them anymore. So, like, for example, those trees, the mountain deteriorates around them. But in terms of angiosperms and specifically monocots, from what I found in my master's, this is the oldest recorded monocot species that has been dated yet, which is really cool. Yeah.
Very exciting.
Yeah.
Thank you.
Add that the Joshua Tree folk actually are not, they're behind us on this one.
Yeah. But they also use the methods of like repeat measurements to try and figure out how old they are. And I think that they've estimated around 300 years old.
Okay. Super. I see that we've got a hands up from Marty Jasper. Marty, would you like to go ahead with your question?
Yeah, cool. Thanks very much for a really interesting talk and some fascinating trees and all sorts of other elements. I mean, all these succulents, the little I think forbs or whatever they're called. You mentioned the poaching problem. Is that also a problem still for the quiver trees? And I mean, from what it sounds like, poaching is a tiny piece of the problem. If the habitat and climate change and whatever happens, poaching is going to be almost a tiny thing. But Joe, what sort of percentage, or how bad is the poaching amongst the quiver trees, and just in general, maybe talk a bit more about the poaching, please.
I'm happy to jump on, and I'm going to pose a part of that to Kayleigh. Marty, I love your background.
Thanks for changing
Beautiful. Look how healthy that tree looks. Makes my heart happy.
It's in the Tanko Karoo, so it's not a Namibian one, and it is our photo.
That's why it looks so healthy.
Yeah.
So actually, the poaching on quiver trees is not very large because they are easy to grow. And I see Peter Archdale's got a question on that, which I'll refer to Kayleigh. So quiver trees not so much. And the tree aloes, yeah, they're quite easy to grow. But the other little succulents are being taken out, and the value of them is huge. So they've actually moved beyond succulents also to some of the bulbs. And I recently learned that some of the clivias, and I forget which one it is now, very rare one, they came in and took the entire population, and the individual bulb was going for 80,000 Rand a pop. So the value of this trade is huge, and we haven't got a handle on it. And it keeps shifting. It used to be kind of phytums, now they're out of fashion, and it moves on. We're just always a little bit behind the curve. So that is a really serious issue. We're losing huge amounts of our flora. There are 2 extinctions due to it in the wild. Yeah, it's really a big thing, and it's not just South Africa. The same thing is happening with the cacti succulent areas in the Horn of Africa for some reason, and it's just ornamental plants. People just want them on their coffee tables. It's crazy.
I mean, so if you kind of go to a local nursery or whatever the case is, are those likely to have been removed from the wild and poached? Or, I mean, is there a way to almost check which ones are right, which ones are wrong? Because I mean, yeah, I know people that love these things. Like, should you be telling them you're naughty, you shouldn't have them, and go put them back? Or like, once they're there, what can you do? I mean, I'm trying to sort of understand. And then, I mean, obviously the whole cycad thing is also terribly bad. But I'm glad to hear that the quiver trees aren't in the same boat as the cycads.
If I can jump in there,
Yeah,
this is
go for it, Kay.
definitely my special interest in terms of how to kind of solve multiple different conservation issues at the same time. And growing stock of plants is one of the best things that we can do, or like having stock of plants available. So with the quiver trees, there was a period of time, I think in the early 2010s, where they were fashionable for poaching. There was a lot of people in Gauteng that wanted them in their gardens, and then there was a lot of juveniles that were removed from populations. And then as soon as they got to Gauteng, then they got planted and they rotted because they can't withstand high amounts of water. It happens in Cape Town as well. But so the trend went down, like Wendy says, these trends go like up and down with the different plants that are getting poached at different times. But as a response to poaching, it's important to grow plants in nurseries, not only to reintroduce into the wild, but also to try and sell to people to stifle the demand for them. But we're not there yet in South Africa. It's difficult, particularly for the reason of it's difficult to tell who is certified to be growing and selling these things and who is not. So I think the best way, if you go into a nursery and see something that is a highly poached specimen, just ask the person who's growing it, hey, do you have permits for this? And if they start like itching in their pants a bit, then it might give it away that it's not necessarily right. Also, if you see lots of old specimens of plants, those are usually the ones that have been taken out of the wild because they take extremely long to grow from seed. And that's why we see a lot of poaching, because people are not wait for them to get bigger, to look like the thing that they want it to look like. But it is hard because we appreciate them and we want to have them in our house and we want to look at them up close and experience them in that way. But we just don't have a direct line to doing that safely yet. But hopefully we'll get there. Yeah, I think we are heading in the right direction in that regards. But it's a good question.
And hopefully the enthusiasts can actually become the conservationists with a bit
Yes.
of more education, because I think
Yes.
often it's like that, even with wild birds, etc. People who start of oh, this is cool, actually then understand the conservation impact and can
Yeah,
be
and
around.
with collaboration. And there's examples of that happening in other endangered species around the world. So like the Wallaby pine in Australia is the best example. They discovered it. There was only a few individuals, and they immediately, the conservationists, got seed into germinated seed and grew thousands of them. Now there's no chance that the thing will go extinct in the wild because there's already material, you know, it came from, it's conservation level material. And it's the model that should be followed, but it's resource intensive and it's difficult to manage. So yeah,
Thanks.
Cool.
Thanks for the talk. It's
Thanks,
great.
Marty. Thanks, Marty. Thanks, Kayleigh. I see that Peter Archdale's got his hand up. I'd love you to ask another question, Peter.
Yeah, thanks. Hi, that was very interesting. And from 2 points of view, I was very struck with some of the challenges. I'm living in Ireland at the moment, although a frequent visitor to Africa. I find the issue, firstly, of climate change and what constitutes what we'll call the new biodiversity of an area, very interesting. But then when you started talking about the poaching issue or the increasing public interest in these, there's a delicate balance to be struck, because on one hand, you also risk the appetite, increasing the appetite for taking those plants from the wild, regardless of how many people appreciate the risks to that population, particularly when you're dealing with a very long-lived, okay, so one that's yay high mightn't be what people want, and so forth. So I was really just going to make the point that I think there is a lot to be learned from what's been going on in Europe for quite a while and in America, not so much about the detail, but about the, I'm going to say, the social approach to these issues. And you touched on that with the Wallaby pine point, but in general, how do you protect a population, increase awareness of the risks to that population, at the same time as helping that population adapt to climate change, whilst not impinging on too heavily on the environment? 5-6 word answer, please.
Peter, it's a very similar argument to the rhino horn trading, right? The good thing here is that these plants produce a lot of seed, and particularly the succulents grow really quickly and actually quite easily. So it's surprising that people go to all the trouble of poaching the little ones when they could be growing them. So one could supply the market very easily. And we're looking into a project investigating the feasibility of working with the local communities to make a nursery in our parks at Richtersveld and Agrabis and Namakwa. So a little bit of the kind of we know those are the folk who know where the plants are. So a little bit of turning the kind of poacher into the gamekeeper idea.
No, thank you. I hope it isn't, as I've seen, we have a habitat, particularly along the northwest of Ireland, Macaire, which is a coastal habitat, and I've seen areas that people have taken a turf cutting machine in and cut off several square meters of this and just put it into their garden with no idea, just because it was pretty. And I think that aspect of it is, that is the risk, essentially, that we generally take by broadening the audience, shall we leave it as general as that. People take the cheap, quick, and not necessarily effective methods.
Yeah.
Absolutely. I wish there was a silver bullet.
Yeah.
Yes, I would use it quite frequently. Thank you.
Thanks, Peter. Wendy, I saw that there was a paper by you. I was doing a little Wikipedia search on quiver trees, and there was a paper that was written by you in 2007 with Prof. Midgley and a few others. And the title was "A Changing Climate is Eroding the Geographic Range of the Namib Desert Tree Aloe Through Population Decline and Dispersal Lags." I just wanted to ask you what a dispersal lag is.
So
Did I
that
miss
is
something
that.
from before?
No, well, so that's that question where I showed you the soldiers all marching and everybody wanting to know, were they going to actually so where the climate had shifted and was now suitable, were they actually going into that newly suitable range? Were they're doing their march? And the answer is no. And we don't know why not either, because their seeds are wind dispersed and there's plenty of wind. They grow actually quite easily. We know from the nurseries that it's easy to germinate the seeds and the conditions are great for them where they are. So we don't know why they haven't really moved. And then there comes the question of, so do we do it for them? Do we help them? And as we saw on Marty's farm, they do just great in the Tankwa area, Calvinia area, and if we there's no reason they shouldn't be further south. So they're becoming ethically less even questioned these days, and if that's what it takes to conserve a species, then we typically do it. I wouldn't say it's necessary for the quiver tree because they still have so many in good, so many healthy trees. But for the giant quiver tree and the maiden's hair quiver tree, the two with the tiny ranges, that's exactly what we plan to do.
Thanks, Wendy. Do I have any more questions coming up from the audience? Yeah, maybe as I can't see any more questions, Kayleigh and Wendy, would you like to leave us with a sort of a final message? Hopefully a little bit of hope and just a nice message that we should that you really would like us to take home with us.
I see.
Oh, wait a minute.
Yeah.
Before you do that, let me just ask Johan to ask a question. He's just put his hand up, so you can think about that for a little bit.
Hi, Wendy. Hi, Kayleigh. Wendy, I saw you lost in the forest in Asna. The question that you had right at the end of your presentation, I'd like you to answer that, please. I think we're all waiting for an answer on that one.
So I think that it's crucial. Particularly our youth are really afflicted by what on earth to do with a future that looks like this. We tell them this information, and it's not like the oldies who are kind of already on this like momentum, and we know what it's like. It's going to be the same. They haven't got that mental impediment that we do. They freaked out by this future. So we really need, as scientists, I think, to deliver this information with that message. Now, I wanted to add it to this talk, but we overran a little. It's a process that we're starting to develop. And I've been drawing on a process called the work that reconnects. There's a book called How to Face the Mess Without Going Crazy, called Act of Hope. And I've been working with students and groups on engaging with, firstly, what we absolutely love about nature and what how it makes us feel. It really charges us up, and it's a beautiful thing. And we all have that personal relationship with it. Then we see this destruction and we get really upset, really frustrated, angry. A lot of horrible, difficult emotions that come when we see these things like I showed you. I mean, these hippos lying there just suffering. It's very hard to see that. And the importance of grappling with that and not just heading straight off to optimism and a happy message, because that's not where real drive comes from. So being able to hold that space of like, this is really serious, this is really bad, I'm really upset about this, I'm really angry. And that's the place from which your passion comes for actually doing something about it, for getting out and making a noise. And then the thing is, so what is my way? Like, what's your individual role? What can you personally do? What are you going to choose to do? There's actually quite a lot each of us can do. And it relates to what your talents are and what you're doing. I mean, if you're a business person, you can take it into your business realm. If you're a musician, go and write songs about it, or an artist. If you're a scientist, or if you're a lawyer, there's a lot that all of us can do in our professions. And then also just talking to people, just bringing it into public awareness, making it mainstream, daring to step out and not, sometimes you're not sure if people are going to tell you you're crazy for believing in climate change. Just bringing into public discourse, popular discourse amongst your social groups. And I think one of the last big things that I'd love to leave you with is nature's forever generous. It doesn't stop. Even, we go into these areas with these beautiful trees and they're still magnificent. They still charge us up. Even amongst those, those areas with all the dead trees, they're still beautiful. Nature's there to keep us charged. So when you get discouraged, when it all seems like it's a bit too much, just go and get in the ocean, go into a forest, get into nature, and it'll remind you why we need to do things. And also, I'll give you the energy to do it.
Yeah, that's perfect, Wendy. Thank you so much. I know Johan would resonate with the getting into a forest. That's his passionate place. So yes, had you contemplated at all? Is there anything that you would like to say in closing?
I'll just say briefly that I think when I came across this project, and I definitely obsessed over it because I was struggling to grapple with what climate change is going to do to my future, to everyone's future, and I think that I wanted to work on it so that I could have time to understand it, and to deal with it. And then in going to all of these populations, especially the ones where there's the 85% dead and a lot of the plants around them are dead as well, it left a really dark mark. But I think that what I've learned as well through the different people involved in these areas, the different landowners, the park managers, the passionate people like Wendy, and the people outside of the sciences as well, who have looked at their dying quiver trees and said, oh, we actually want to grow some, we want to try and plant them back. Tell us how to do this, like tell us what we need to do. It's given me a much more practical outlook and something to hold on to. And the one thing, like Wendy said, is that with climate change, it's going to peak and come down. So what we're doing with conservation is essentially trying to facilitate the continuation of life through these really dire circumstances. And for me, that helps me feel a lot less bleak, because it's not just this dark future where everything is going to die off. There is an aim, it's like keep it alive, keep it going so that it can continue to exist. And I do think that that's the right way to go. So that, and finding connection to nature, especially if you can find it through something that helps or assists nature survive these human influences, is a great way of trying to engage with it. But otherwise, just thanks very much for this talk. It's one of the greatest ways of engaging people with reducing plant awareness disparity, and it's an amazing thing to do. So thank you for hosting us. But that's all from me.
Wendy, thank you, Kayleigh.
Okay. I guess another so in where to go, when you switch off your Zoom and close your computer this evening and you kind of mull over what does this mean? And you land up, as one should, being scared and a bit despairing. I think one of the key things to remember, as well as going into nature, is that there are a lot of us working on this issue, and that includes Kirsten, that includes Johan, that includes everybody who's doing their little bit. And that it just seems so overwhelming. What am I going to do about climate change when Trump does this or whatever? You don't have to fix the whole thing. I feel that overwhelm often. Then I remember I'm standing on the shoulders of previous generations who worked on it right back to the 1960s with Rachel Carson. And there will be many generations coming after, and there are people all over the world working on this. So I only actually have to do my bit. I can do the bit that I do and that I can do to the maximum of my ability. And if we're all in a team, then that makes me want to think, okay, thank goodness for Kayleigh, thank goodness for Kirsten, thank goodness for all of you. We hang together and it feels a whole lot less daunting. Yeah, it actually becomes like awesome to be part of the solution, and find meaning in the whole thing. Yeah, pulls us along with extra meaning in our lives.
Thank you, Wendy. Thank you both. You've been very eloquent and very passionate, and yeah, very. I think that we've all been energized as well as being informed about the situation, but very energized as well, which is an amazing combination that you've managed to give us. I see that there's a lovely little comment from Amanda Malson. She says, it's not a question as such, just wondering why this webinar didn't happen 3 years ago when I was still doing my PGD and reading so many of Professor Foden's papers as part of the Conservation in Face of Climate Change module. And a little laughing face. Thank you both so much for an incredibly interesting and enlightening presentation. Your passion and enthusiasm for the topic is obvious and infectious. That's lovely. And then there's just something from Johan, which is just to say, please join us next week again if you want to take if you want to further understand through the COP29 around climate change, and for us all to in our little ways take action.